Everyone thinks you tap letters, but the glass proves you tap pixels, and a hidden target map decides which of 26 keys each tap becomes. Your fingertip lands on coordinates. The phone has to guess what you meant. A real keyboard has raised keys you feel with your fingers. Glass has 0 edges. Every tap is ambiguous. And your fingertip covers roughly 40 to 60 pixels of screen, while a single key is narrow. So your touch almost always overlaps 2 keys at once. Without correction, your typing would be a mess. That is why the phone cannot just trust where you touched. Start with the touch layer. Every key you see drawn on screen is only the picture. Underneath sits an invisible hit target. It is a bounding region the phone actually listens to, and it is larger than the letter you see. When you tap, the phone does not record which key. It records the exact spot, an XY coordinate down to the pixel. Now picture those hit targets laid out. They sit shoulder to shoulder, edge against edge, so the boundary between two of them is a razor-thin line. Here is the problem. A tap that lands near that line is genuinely uncertain. It could belong to either key. The phone can measure exactly where you touched, but it cannot know which letter you were reaching for. That gap is real. That is the zero certainty in the title, and it is not a bug. It is baked into the geometry. Think about it. You have wide fingers, narrow keys, and boundaries you cannot feel. Every single tap near an edge is a coin the phone has to call. So the phone needs something more than coordinates. It needs a way to land the odds, to make one key easier to hit than its neighbor before your finger even lands. Which raises the obvious question, how could it possibly know that in advance? Here is the trick that makes it work. Those hit targets are not fixed. The keyboard resizes them in real time, silently and visibly between every tap. This is the stretching map from the title, and it is the heart of the whole system. Watch a real example. You have just typed T then H. What comes next? In English, the is one of the most common words there is. THR and THW barely exist. So the moment you finish TH, the invisible target for E quietly grows. It swells outward, claiming more screen. At the same time, the targets for R and W sitting right next to E shrink back. You see none of this. The letters on screen do not move a pixel. But underneath, the map has already tilted the board in favor of E. What is doing the tilting? A language models. A program that has read enormous amounts of text and learned which letters tend to follow which. It is constantly predicting your next likely letter and biasing the invisible map toward it before you tap. So when your finger lands a little off-center near the ER boundary, the stretched E target catches it. The phone did not read your mind. It played the odds. But letters are only half the story. Because you are not typing letters. You are typing words. So how do taps become a whole word? Here is the part most people get wrong. The phone does not lock in each keystroke as you go. It keeps the entire path. Every XY coordinate from your whole word held loosely as a cloud of probabilities. Nothing is final until you finish. Then it runs a kind of contest. It lines up candidate words from its dictionary and scores each one on 2 things at once. First, how well do your actual tap locations match the letters of this word? Second, how common is this word in real writing? Both votes matter and it weighs them together. Take a classic. You mean to type the, but your taps land in the Te region. The E and H a little swapped. 2 candidates step forward. Te matches your taps almost perfectly, but it is essentially not a real word. The is one of the most common words in the language, and your taps are close enough to it. So the wins the contest. Your fingers said Te. The phone typed the. That single decision, tap match versus word frequency fought out over a cloud of coordinates, is autocorrect. It is not fixing a letter. It is choosing a word. But if it is always betting on the common word, what happens when you actually meant the rare one? Here is where it turns against you. The whole system optimizes for the common word. So when you type something real but rare, a friend's name, slang, a brand, the phone sees a word it does not know, finds a common lookalike, and overrides you. That is the entire damn you autocorrect genre in one sentence. The map betting on the ordinary when you meant the unusual. But it does not stay dumb. The keyboard learns. Type a name enough times and it adds that word to your personal dictionary. It even tracks your own tapping habits. If you consistently land low and to the left of the spacebar, it quietly shifts your targets to match your thumbs. Over weeks, the map bends toward you specifically. And this is the zero certainty idea finally paying off. The phone is never sure. Every correction it makes is a bet. This word, not that one, placed with incomplete information. What makes it feel smart is not certainty. It is that it updates. Each tap you make becomes evidence, and it revises its odds on the next word. It is wrong sometimes because betting means sometimes losing. So we have got coordinates, a stretching map, and a word contest. Time to snap them together. Now watch all 3 numbers locked together. One stretching touch map. 26 keys that look fixed but never are. and zero certainty on any single tap. Put them in one line and you get the truth. Your keyboard is running a non-stop probability guess. It is not reading letters off the glass. It is placing bets. 3 voters weigh in on every word you type, where your finger actually landed, which letter the language model expected next, and how common each candidate word is. They vote, the loudest combination wins, and that word appears. That is it. That is the machine. And it reframes a feeling you have had 1,000 times. That eerie moment when it fixed a sloppy word and you thought, it knew what I meant. It did not know anything. Before your finger even came down, the invisible map had already stretched toward the key you were probably reaching for. The catch felt like understanding. It was really just good odds, computed faster than you could notice. So here it is in one line. Your taps are just coordinates, and a shifting probability map turns them into words. Next time your keyboard quietly fixes a typo, watch it happen. And remember, it was not reading. It was betting. If your fingers can bend a map, wait until you see what predictive text does next. Subscribe and we will open that box too.